Hello. So today we're going to talk, or right now we're going to talk about FVM interfaces and data a bit. This is like, so it's a bit of a mashup talk because they're two slightly separate problems. One is like how actors call other actors. One is how actors store their state. But they're related because both of them have to do with tooling, as in like all the libraries and code gen we want you to do to actually have one actor call another actor and not have to pull your hair out to do that. And then the same problem happens with storing state, where like ideally you would have some way to describe how your state should be structured, how someone might want to read it. You might want to have some nice tooling to actually be able to like easily just read the state in without having to like walk through a bunch or jump through a bunch of hoops. Where like at the moment you have to say, kind of like say, okay, hey, load my state. Oh, here's a CID. Please system load the CID, decode it into this block, and it's a very manual process. And really this talk is about thinking about like how we could improve on this. And also comparing it to Solidity and how Solidity does it and why it's so much simpler than Solidity. Well, Solidity has a lot of other problems, but it's like for writing like smart contracts that serialize their state and call each other, it's much simpler. Okay, so let's start out with some background on Solidity. So this is a basic Solidity smart contract. You can see at the very top there, we declare that it is a simple coin contract. The first thing we do is we declare a mapping of actor address, or sorry, I guess this is smart contract address to UN256 because it's Solidity, or it's EVM. The constructor just sets one value, and then you can define a function like this, or a method. You say like the method's public, you specify what it returns, and then you can just sort of modify the balances and do whatever you want here. The really cool thing about this is like you'll notice you're not saying like save state, create state, or anything like that. You're not calling the system, you're just reading variables and writing variables, but that is implicitly doing everything you need to do. Where like when you define that send coin function, that's actually defining an external function that anyone can call, and you know that because it says it's public. When you, for example, write balances, brackets, message.sender, minus equals amount, that kind of stuff, that's actually modifying a quote unquote slot in the system. That's basically, so the EVM is based on slots, where you have a 256-bit address space of slots that map to 256-bit values. So it's basically one massive or sparse hash table of 256-bit keys, 256-bit values. And Solidity, what Solidity does, and this is basically the magic sauce of it, is it maps some nice, like a nice programming language and data model down to this like infinite hash table, basically. That's the idea. One other cool part about this is the Solidity tooling will output a bunch of metadata about your smart contract. So for this smart contract, you'll get something like this out that will specify the structure of your storage. It'll basically say, hey, we have a single slot, and it'll tell you where it is in the code just for debugging. It'll tell you it's slot 0, it'll tell you the type, and then it'll list the types. And you can sort of walk through this and like figure out the structure of the data. This is very specific to the EVM and Solidity, which is the downside. But this does let you like write tooling to like explore the state of your smart contracts by just reading this JSON file. Solidity will also generate these ABI files for you. So like it'll generate a function, or the first file from the left, a list of function signatures. It'll also generate a list of what are called event signatures. Where this is actually very much like FRC42, where you have a function selector that references a function, tells you the parameters of the function, basically. And then on the right, you'll see the JSON version of this. It's more verbose, and that's usually what's used by tooling. So that's how Solidity works, and that's why it's so much simpler to program in. It's also because like, especially when you're using Solidity and you're like importing another contract, you can then like literally directly call a function in that contract, and it'll just translate it into a cross-contract call under the hood, and this just makes it easier to quickly program in. Okay, so in the Filecoin world, where like, on one hand, we get to use Rust, which, to be very clear, is a much better language than Solidity, at least in my opinion. You get to like use actual data types, generics type, like real libraries. It's a richer ecosystem, a richer type system, fewer gnarly like edge cases that you might get in something like Solidity. Downside is like it's not designed for smart contracts, so it does make trade-offs that you actually don't care about smart contracts. For example, like smart contracts, you don't actually care about ever like freeing data, and a lot of the complexity in Rust actually comes from like data life cycle or lifetime management, and it's kind of pointless in smart contracts. But oh well. But yeah, this is an example of how we do dispatch in the built-in actors. We have this macro basically that just like dispatches methods to, method names to methods, and these method names there actually unfortunately didn't include in the slide. Those are actually in one big enum. They just like have effectively numbers for every single method, but it's still pretty manual. Then to actually like work with state, what we do is we first define a state object. We say this. We basically use serial to describe how it serializes and deserializes from CBOR, and then we implement a method, and this method basically just like asks the runtime for the state, decodes it. There's some magic here, which is nice, which like you don't have to like explicitly decode anything because like Rust has return type overloading, return type polymorphism, I guess. But still, you have to like load your state up. In this case, we're just reading it, but like if you're updating it, you actually have to then like say you have to like put the state back, which is still kind of annoying. In terms of calling, this is, for example, a mint function that I pulled out of the built-in actors. And you notice you have to basically, like, you have to create these parameters. You then have to, like, you have to call send. You have to specify a constant as, like, the function you're calling. Or sorry, not function calling. You have to specify, like, a constant address. You have to specify the function you're calling is, like, just a number. You have to then serialize your parameters. And then when you, for the return value, you have to then deserialize your result. And it's, again, like you have to, a lot of this is manual. You have to do a lot of manual error handling, where one of the nice things about Solidity is you just like say, like, effectively, it assumes that if there's an error, it'll just abort. And you have to explicitly try to catch errors. It's one of the nice things about Solidity, where like it's, I don't know, it makes it so it means that you're not distracted by all the error handling code and all of the rest of like the serialization, deserialization code. You just get to see the pure logic. This can get you into trouble sometimes, but most of the time it works just fine. Okay, so now I want to talk about the FVM. So that was just some background on Solidity and the FVM and like how they differ. This is really what I want the meat of this discussion to be about, and this is where it becomes interactive. I really want to talk about how we can make like programming in the FVM and the built-in actors as simple, or at least simpler than it is now. Or sorry, as simple as Solidity, or at least simpler than it is right now. The topics are basically, first of all, the ABI specification. We've tried to figure out several different ways of specifying the ABI, or the interfaces or I guess API specifications are written, of the built-in actors. The first one we tried was something called AdaWise. If you go to that GitHub repo, you'll find it there, or the sort of like some research on that format. It was a very IPLD native interface description language. The biggest problem with it is like it's homegrown and IPLD native, which just means like there is no tooling written around it, and like we would have to like basically make it happen and take it from a prototype to something that actually exists, which is my biggest concern, and the reason I'm not sure if we should really push for something like that. The next idea is to take something like IPLD schemas, which are still our own thing, but at least a little more mature and used in a few places, and then just throw in FRC42, because we can literally like effectively have like very basic method signatures where we just map like FRC42 dispatch numbers to an input and an output described with IPLD schemas. Another question here is like, would WIT work, or Wasm interface types? Where like in theory we could specify the interfaces for actors using Wasm interface types, and then find some way to map those onto IPLD schemas. This is what IPVM does, at least as far as I understand. And this would mean that you could just write your Rust code and then just use Wasm tooling to just extract the Wasm interface types from that. I'm not sure if we do use that as the exchange, as the only exchange format at least, because that may not be able to capture all of the features of IPLD. It may only capture like the Wasm side of things, but it's still something to talk about. The second part of this is state specification. We can use IPLD schemas, or maybe something simpler, or maybe this way to use Wasm interface types. Again, with both these cases, I want some way to auto-generate these schemas, so that we can then auto-generate code, or so basically we can write the code, auto-generate the schemas, and then generate code in some other language or some other like actor to just make this easier. Yes.
Are you taking questions?
Yeah, of course.
Okay, excellent. I guess one question I have with regards to interoperability, because like a lot of like like you see down here, state access, very different. Interface is very different. Arbitrum they just released Stylus, which has fully interoperable, like WASM-based actors that you can deploy.
That is really cool. Okay.
Have you heard?
No.
Okay. I highly encourage you to go see how they did that. Right?
Thank you.
Because you can write Rust or C and interoperate with Solidity seamlessly. So they've probably done something there. I'll dig into it and maybe send you some links. It's called Stylus.
Thank you. Yeah, that's exactly what I'm looking for. And the tricky part for us is we do have IPLD as like this standard interface format, so interchange format. So probably need to find some way to at least map whatever they're doing down to IPLD at the bottom layer, but that's usually possible.
Yeah, at a minimum, if we dig into it, we may see where, what dragons they slayed.
Yes, exactly.
Yeah, save a little bit of time.
And I guess the final thing I want to talk about is, I guess, state access. This is something that I think actually is more like, so the interface types and description language and stuff like that are more abstract and going to be more of a design process. State access, though, I think is something we can actually solve now by just writing some nice libraries. And I want to sort of walk through, this is something I've shown a few times, but like I haven't really dug into it with anyone. I want to walk through like sort of a design idea that I have in terms of like how I think we should be accessing state, and then get some feedback on that, and maybe try to find some way to like prototype this and have this actually happen. And that's this. Basically, I really want to, so currently with state in the built-in actors, we very explicitly load objects, store objects, dereference CIDs, load hamps, stuff like that. I would like to move something more like this, where we just define a few structs, and then the structs can have links to other structs, and then these links auto-deref. So this is like very magical, and you'll notice there's no error handling here. Because my assumption here is that if the state you are storing is invalid, you should just abort. Because in general, that's what you want to do. You don't actually want to handle invalid state in most cases. You usually want to just say, you know what, like this means there is a bug somewhere deep in the system. I just need to abort. Now, we probably do want some way to recover or to load state in a way where you don't abort. And this gets tricky because I don't think unrolling has been implemented in Wasm time yet. Have they finished it? No. Okay. So once unrolling, or sorry, once unwinding the stack, I guess, has been implemented in Wasm time, this will be a lot easier because you can actually catch exceptions. For now, we'll have to think about how to do this, but like usually you still only want to catch exceptions or catch errors, or like state errors at actor boundaries. You don't necessarily want to catch them like within an actor. So I just feel like this could significantly improve the experience of building native actors. This is also actually not too hard to do. Effectively, what you do is you implement this special link type, and you make it so that whenever you dereference the link or immutably, because it's Rust, you actually get a difference between immutable and mutable dereferences. So when you dereference it immutably, you will load the state, or like the reference state. If it's not already loaded, then you'll cache it. Then you'll let people like do whatever they want to it. If you dereference it mutably, you would then mark that state as dirty. And then at the end of the function, or like maybe at some explicit like point where you call like transaction store or something like that, or transaction finish or commit or whatever, it would actually commit the state. So I wanted to bring this up because I feel it would just make like programming in the FVM a lot easier, and I want feedback.
Hey, quick question. Would these accessors would be able to like put them in a macro so you can just use them as the dispatches in a similar fashion?
Sorry, what?
These accessors, this seems like a boilerplate code, so we should be able to put them in a macro and just access them through that.
So the problem with that is like, well, I don't know how to write that macro. That's a really hard macro basically. Because like, that macro would need to like, it would need to, okay, I know how to write that macro in Lisp. But the rest AST is a lot more complicated. So you basically have to have the rest AST, or you have to have a macro that sort of ignores most of your code and only looks at like the state access code, and then somehow like modifies that. It's a lot easier, I think, to just do this with deref, because then you just like you have basically you implement the special trait called deref on this link type, and then whenever you try to basically, whenever you do like the link dot something, or whenever you try to access the underlying data, it will just like automatically say, oh, you need to dereference this smart pointer, because that's what that is, a smart pointer, and it'll load the state. Does this make sense?
Yeah, thanks.
I'm just wondering if people have like other reasons why this shouldn't happen, where they think the failure boundary should happen.
I strongly think it should happen.
Okay.
I especially like the thing that you should just, if your basic assumption about the data being there or not fails, you should abort. That is not a recoverable error. It should end. And we can lean into the blockchaininess of this and just be like, hey, that didn't get persisted. You need to fix your code.
Yeah, the tricky part is like you might have cases where you actually want to say, you know what, like I need to proceed regardless. And we do have cases like that. Usually we do this at the actor level though. So like we'll have some actor A that's calling B, C, and D, and if like B fails, we want to continue in actor A. Usually we don't do this at like the individual actor layer, but sometimes we actually do. Where like, again, we have something that's just wrong. We're like, you know what, like failing here will be really bad for the system. We're not going to do that.
Yeah, so whenever, like, there's the distinction between an error and an exception, right?
Yep.
It's like recoverable or not,
Yep.
basically. Anytime it's recoverable, that, like, as a best practice should be explicit as a result type, right? Yeah. And then really quickly on the macro versus not, sure, we could clean this up, and I have some thoughts on like how you could detect those things and whatnot. We've started using a lot of new types to detect things in macros in Rust, but at the end of the day, the underlying interface is this, right? So like I still think this is the right level of abstraction to think about, even if you clean up the interface, right? So. Yeah.
I also do want feedback from Alex because he's the one who writes most of this code, at least the one who's in the room.
So, error handling patterns in the built-in actors, I agree we should, move towards just aborting low down. That's merely a conventional change that we could do independent of anything else here. After that, I wouldn't say this is very high on my list of stuff to improve. It's not bad, but I'm a bit concerned that the magic involved would end up confusing people, consuming a fair bit of time. It's not that hard to write the boilerplate involved in following a link. There's other boilerplate like more abstract data structures that is probably more valuable to, using a HAMP is a pain in the butt.
Yeah, so like one of the goals here would be to use the same kind of like implicitness in HAMPs and stuff like that. And the other reason I want to do this is actually performance. Because if you have something like this, you can do a lot of automatic caching. Or like right now, unfortunately, what we have to do is we have to make sure to like pass around like references to a HAMP so that we don't have to reload parts of that HAMP. With this, like you could just sort of like as you load things, you just never unload until you're done with the function.
Yeah, I think there is more. There are more patterns we could build there. Again, without necessarily being so magic. Okay. Another thing to consider is anything that we did here. I'd want to be, you'd have to work hard to break the transaction pattern that we have. Like we have this transaction pattern of, I'd want it to fairly clearly fit into that.
I think this can fit into that. So right now I'm doing this at the method level. You can do this at the transaction level if you just instead of having you take the state as a reference, you basically just take a reference to the system, and then you have to call .transaction, and then you get a callback that has the state inside of it. But so you can use the same pattern with transactions. It would mean though that once you end the transaction, you just lose your entire cache.
And could some of these problems be solved on a higher level, more on a SDKs or tooling level?
Well, so the idea here is to make effectively an IPLD SDK that has these magic types that just automatically load CIDs.
Because what I experienced, our motivation, what I think our motivation is to enable people to write these actors without having having to learn all the stuff
Yes.
that Alex has in his head after working on actors for years, right?
Yes, but my guess though is at least at the moment the first test case would be built-in actors. That's why I'm asking, because he has the most experience with this, and it would we would definitely be testing it on that kind of thing.
I agree. I'm very habituated to how we do it now, and so probably not the best person to ask about whether doing it differently would be better. To me, it involves a relearning cost that is
makes sense.
Not relevant to other people. Of course, you've got to enable us to write Wasm actors first.
Probably wouldn't use this SDKs anyway, right?
then I also actually, Brooklyn, how do you do this in IPVM? Like, how do you have users load state?
So sort of two answers. The main interface is completely stateless, and so you hand everything around directly by reference, like to top of.
But like, let's say someone passes you a
structure.
CID,
Yeah.
and you need to like load some tree of
Then under the hood we have a like a block store interface where you say, hey, give me the next block, give me the next block, give me the next block. This is the thing I was talking about upstairs,
Yep.
where we need to guarantee that the data is available,
Yep.
right? We convert that into a content handle, and then that gets threaded through the system. And then from there, we use like very straightforward Wasm components, like stream stuff, basically.
Well, so I'm thinking like, okay, let's say like I have some root, like in this case, like this root state object,
Yeah.
and internally it has a CID. Like, how is, like this is actually going back to my question earlier, like how is this gonna be represented as a Wasm interface type? Like what would that metadata be? Like what would the type there be?
So at the level of the interface, it's just the CID. I
Okay.
mean, like, again,
So-
under the hood, we convert it into a non-serializable type for like analysis reasons, but
But I mean like, so I'm the user, like I'm writing my code in Rust. What, I just put a CID there.
yeah.
And then do I have to ask the system like, hey, here's a CID, please load the data, or what, how does that work?
Then you use this interface that says like load block, and so it's a block
Okay,
store interface.
Okay.
Yeah.
Yeah, okay. No, I was
It-
wondering.
it-
I was wondering if you had some magical way of doing this, like I'm trying to propose here, where like you had like some way, like, because like this is also where I got to the handles, where like I was wondering if you had something where you said, hey, like I see that you specified a link, an abstract link here. I'm just going to turn this into a handle immediately, and when we try to access it, we just dereference it magically. I was wondering if you did that.
So like basically yes, we turn like we need to know who to blame if the data is not available, because
Yep.
we have a data availability
Yep.
thing, right? So we get a reference to the data, and that might be on machine, that might actually be over the network. Unclear, right? We just have a promise that it's available, right? And that's essentially, like, you can think of that as being like a new type wrapper around this, right?
Okay.
And then from there, it looks like it is literally the block store that we modified from the FVM.
Okay.
Yeah.
Actually, I want to talk about that very quickly. It's a bit of a sidetrack, but like, how do you? So like, we have that same problem, and the way we do it is whenever you load a block, we read that block and find all the links and say that if you had access to the block, you must have access to all of its children.
Yep.
Is that you do the same thing?
Yeah. So we've had a few people ask for like, hey, what if I only need like the top 3 blocks and I don't care about everything below? It's like, then you should create a new data structure, right? At least to get started, that's probably good enough for like the 99% use case. But it does mean that if you only need to read like the top 3 blocks off of a petabyte of data, we guarantee you that the petabyte is available.
Okay.
Yeah.
Got it. Yeah. Then I guess like, okay, we'll talk later. But like, actually, I want to unify in those functions because like for us, like we found like I didn't want to do too much validation, so I wrote like a very simple CBOR parser. That just pulled out the links. It didn't do anything else, or adapted one we already had. And I want to make sure, like, I want to make sure the ecosystem unifies on like how we do that kind of thing. But okay.
Yeah,
We'll
yeah.
talk about it
The short answer on that is we treat it lazily, and we take the guarantee from the provider, who we will then slash if they lie to us.
Got it. Okay.
Yeah.
Makes sense. Okay. But actually, I would like to hear, if you have a moment, a little bit about how, like, so like you already talked about a little bit about Wasm interface types. But I was wondering, like, how does it actually work in practice? Like, I am like some IPVM program, and I'm calling another IPVM program. Do I just import some Wasm interface type specification from the other program? How does that kind of thing work?
So in our system, it's literally off-the-shelf Wasm components, plus like everything that we've added to it are also components. So we essentially inject this tapping function so that we can get the output out and sort of like async turn them back into IPLD at each step, right? And then we just thread everything through. Component model, you have what they call a world, which is basically like the wrapper, like with the header and everything on it. And then when you hand that off to Wasm time, it knows how to join those together so that it's a single
use Wasm
execution.
time for linking.
Yeah.
Got it. Okay. Yeah. So like, unfortunately, our case, we have to mediate that sending and linking. So like so we can't quite do it that way.
So we do this sort of like dynamic thing where only if it's only the modules that are going to get executed on a single machine get linked, because there might be a network call in the middle, right?
Yeah.
Why can't you link them together directly?
So like, because here we're doing actor-to-actor calling, and the actors live, like, they have different memory, they live in different, like, they have access to different state, and the way we do actors also, we load it up, call it, and then shut it down each time. So
I see.
it's,
Yeah, so you, okay, because you don't, right, because in your case, I guess it's, and maybe this is some of the stuff you're asking about upstairs, it's like Turing complete what could get called. And in our case, we know it statically.
Yeah.
Okay, yeah.
So, well, it's not, no, we do know statically, well, no, actually, right, we don't know anything. Yeah, we really don't know anything. So, like, you just call something, and, like, so what we can do is we can potentially use Wasm interface types, and then have some shim that converts that down to IPLD and lets you do dynamic calls, but yeah, all of our calls are dynamic, effectively.
Yeah, the other thing you could do is, in theory, you could leave the data in like the Wasm type without doing serialization, and essentially use that for like dynamic linking. I haven't seen anybody. It's something that we had talked about early on, but I don't think I've actually seen anybody do that. The other thing you could maybe do is, you know, like realistically, there's a huge number of cases. I would even say like the normal case, you know in advance. Like even though yes, you could create an address, you know, by bit shifting and whatever, right? But like people basically don't do that because structured programming is awesome, right? So you might actually know in advance all these, like all the steps, and you might be able to runtime link them.
Not really.
Right? Like I don't. Unless there's some reason that you have to pull them out individually, like you'll get a performance advantage from treating it like a single program.
Yeah, unfortunately, I don't think so, because like the way our transactions work is like you run some code that digs through your state and decides based on your state and the inputs what to call, and then it calls it. So like this is like it's very much like the EVM, where like you dig through your state and you figure out, okay, I want to call this other actor, that kind of stuff. So like it is very dynamic. Like you could, like, if you had something more like Solana, okay, fine. Like there it would be easy. We just link together all of your accounts.
But you know, even EVM, except for inside of inside of a smart contract, you have unrestricted jumps.
Yeah.
Right.
We don't have that yet.
But between contracts, again, like the normal case, like really very high number of cases, like 90 some odd % of the time, people hard code the contract addresses. And this is a thing we were looking at
You're
for
right.
performance, yeah.
But like understanding that is going to be harder. Like actually like trying to pull up that address and figure out where it is. Like that hard coded address is probably not going to be in your code. It's probably going to be in your state somewhere. That's my understanding.
It's usually in the, at least the smart contracts that I've seen, and maybe think people are using Filecoin differently, right? It was usually in the code.
Oh, okay.
Like we could analyze the solidity and like. And
I expect it'll be in the state. The main reason I expect it'll be in the state is that like solidity doesn't give you any benefit. The EVM doesn't like there's no benefit or very little benefit for reusing code. Like basically you reuse code by reusing it. We're using like smart contracts on chain. You don't actually reuse code blobs. Yeah. The FVM is very different. Where like you point to the code by CID, so I expect people will deploy code once and then just repeatedly refer to the same code blob and then like have some other state that.
Right, but then why wouldn't that? We can take this offline. Yeah. But the main question I have is like, why wouldn't that be in the code? Why would that be held in?
Because it means you can parameterize then parameterize the code over the state or with the state. It's like my understanding is with the EVM, people they will literally go and copy paste some Solidity code, change an address, and then upload that. In the FVM, I don't expect people to do it. I expect people to like say, oh, I want to use this FVM smart contract. I'm just going to reuse their code CID. It's already on chain. It's already been paid for, and I'm going to use my own address. So I just expect that's going to be a more common flow.
I see. You're okay. I think I see. Let's take this offline.
Sorry. Okay. Like we are technically done with this discussion, although I don't think Ayush is here yet.
Besides checking Arbitrum stylus, is there anything actionable we can schedule from now, based on this discussion?
So mostly I wanted to like get people thinking about this and try to like source some feedback from people in the room. because we have a lot of, well, I don't know. For example, Scott knows things I don't know, and I haven't had a chance to actually ask him about this yet. I also wanted to get people's opinion on things like that magical IPLD loading. It seems like it's a bit mixed.
I think it is probably it's worth taking note that the built-in actors are probably not the way that other people should write Wasm actors in the future. Most of the patterns there are probably not very good for newcomers.
Yes.
They probably also shouldn't write Rust. They should probably write assembly script.
Yeah.
And so we can build new patterns there instead. That can be more abstract and be hiding some of the details, and be more optimized towards a common case. And if someone really needs to optimize or do something tricky, maybe they have to fall back to Rust and I mean, they can still, or skip the helper libraries in assembly script.
Yeah, that's a good point.
So like do it all, start from scratch and even use a different language.
I guess this might be more of a question for Alex. What is assembly script, and why would somebody choose that over Solidity if they're not getting the Rust, performance?
They will get the Rust performance because it's still, mostly because it still compiles to Wasm. It's basically JavaScript that compiles to Wasm.
But it's a subset of JavaScript.
We had a long conversation about that last.
I mean, sorry, I butchered it, of course, right? The full word version.
No, I wonder. It's a fast subset of it's a JavaScript-looking language, but it's kind of like I think it's like RPython or something like that, where like it looks like Python, but it's not really. It's like that, but for JavaScript, where it's.
TypeScript and Python. That's all I need to know.
Yeah.
But the point thing is, it's like RPython, where it's like it looks like it's JavaScript, but it's not. Like it actually it's much more restricted. You can't eval things and stuff like that. So it compiles down to WebAssembly, and it's much faster.
Yeah, and we built already an assembly script SDK, WebAssembly script SDK, and people were very excited about it. Like, looks easy to build smart contracts. And we stopped development on that because we moved into EVM, but it's still there.
I would actually like to hear how you did access to IPLD there. How did that work?
How we did?
Like, how does access to IPLD state work?
How a state work?
How does access to IPLD state work in the assembly script SDK?
I don't know.
Okay.
No, I didn't write it myself,
okay.
but I can find out.
Okay.
Yeah, sure. Yeah.
Okay. The other question here is like, is anyone really interested in interface description languages or state description languages, or do they have a lot of experience with them and like want to throw out ideas of potential, like, it's like the problem is like we have a couple, but the ideas we have so far are things like, well, we have like protobuf, we have the Solidity API, we have some like the homegrown stuff like schemas, and then like there are obviously examples like SOAP that no one would ever want to use.
Did you really just say SOAP?
Yes,
wow,
I did say SOAP.
Man, it's been a number of years since I've even heard
I
that.
want to, in my defense, I want to say that no one would ever want to use.
Yeah, not even back then did I want to use it. Yeah. I guess one I think driving factor is for like native actors, or essentially non-EVM actors, I think is what we're really talking about. How interoperable do you want them to be, right? Like, would you want a Solidity or a WebAssembly script or a Rust actor to be able to work with each other or not? Because that's a huge driving decision, right?
Yes. However, it's tricky because Solidity already has its API, but we also don't, but we don't really want to inherit all of those words because like it's based around 256-bit words and all this kind of stuff. We could, in theory, take like just the type definitions, but also our type definitions are very different. So ideally, we'd have more of like a translation where effectively like a native actor can call, or sorry, a Solidity actor could call into sort of, you're basically using an FVM calling convention, or a Filecoin calling convention, using some library potentially. And for example, you could use a library in the FVM to call into a Solidity actor using the Solidity calling convention. But ideally, actually, from the FVM, you'd actually call into, how do you put this? Effectively, two different calling conventions. And ideally, you'd be able to call a Solidity actor as if it were a sort of on an FVM native calling convention. This is already, it's technically possible right now where like a Solidity actor can respond to Filecoin methods. So it would be nice to actually be able to then effectively implement like, I guess, Filecoin native conventions or FRCs in Solidity. Of course, this is still an ecosystem split, which sucks. So like we've had a lot of debates on this, how to do this, and we don't know.
Yeah, there's the one true data model and calling convention in Filecoin, which is the native one. Absolutely, anything that's targeting that, anything that's going into Wasm in the interpreter or one day compiled or anything, should interoperate, out of the box with other things that are doing that. Something that's running in a guest VM like the EVM, or so we run the JVM on FVM. They're going to have to do some work, right? There's going to need to be a shim layer, but we don't want to have to solve the quadratic thing, right? That everyone should just have their layers to talk to the native.
Ideally, it's not always possible. So the problem there is that, like, for example, like with Solidity, we don't like. I don't have enough information just by looking at the parameters to actually like re-encode that as something as proper IPLD. Right now, I just have to wrap it in a byte buffer and say that's it, because like the data is not self-describing. So that's a general problem you have for interop. Luckily, this only applies to pretty much just Solidity, because like how do you put this? For effectively, like there are two types of things we have to deal with. We have to deal with other VMs and other blockchain runtimes. Well, the only blockchain runtime we found that we really care about is the Ethereum system. For example, JVM, that's probably not an issue, because something like JVM, like you're probably just going to like use, for example, something like Wasm interface types to specify how to do calls, and then you're just going to convert down to IPLD at the bottom layer, because like there is no specification for how to do for actually how to like serialize Java types across like calls in smart contracts, because it's not a smart contract language. So you only have this problem when you like try to like port an ecosystem from another blockchain, and it's not unclear if we're going to do that again. But
So if we have a few minutes, this question to you and Alex, like, can you elaborate to why normal developers shouldn't write actors the way that they're written by actors? Like, what are the main
differences? Just the way they are now is this huge path dependency from how they started years ago. They were written in a different programming language, ported in a they needed to have exactly matching semantics, so they were ported basically line for line instead of naturally re-implementing them in Rust. Well, it's just Go conventions implemented in Rust.
yeah, whenever you see the forest state, please apologize. Their job was virtually impossible.
Yeah, no one built any like good libraries or abstractions over. Yeah, and then there wasn't even a real VM when they were first written, and then we inserted an actual VM sort of behind them.
But to give you an idea of how complex this was, they had to make sure that all of the IPLD reads and writes happened in the exact same order in Rust as in Go, which meant that like their code, there were some cases that were just really, really tricky to match. And it just means the code's not nasty.
So it's just, if one started again, particularly if one was implementing something simple and all of the people building to start with, they're going to write simple things. You could make it, there are some ideas that should be, I think re-implemented. So, some transaction abstraction, which is just library code, but library code that helps people not screw up. It should be replicated, but it's still opt-in. You don't have to. Now people who know Rust, it's fine. They can use Rust, but I wouldn't use almost any of the code outside of the core like data structures that we use.
Yeah, so as part of the developer experience, we'll need to provide like a bunch of like reference snippets of how you write an actor, right? Yeah. For different use cases. But for like,
Although actually one thing I do want to note is that like there are two layers of developers basically. Like there are developers who are bringing like the complex ecosystems to the FVM, and the developers trying to write smart contracts in Wasm. Honestly, for the first several versions of like, okay, everyone you can deploy Wasm actors, we're not going to be targeting that second use case. Like, if you're just trying to like write a simple smart contract, we're going to say, use the EVM. You have your tooling, everything just works. But like, the problem is like, if we wait until we have all of the tooling and the documentation and everything together, it'll take a very long time to get to the point where we can actually legitimately recommend like random developer just go and like write a smart contract in like assembly script and deploy it, versus like if we like the other option here is to say, okay, no, we just release support for WebAssembly now and let people start hacking on it, but we're only encouraging people who really want to like work on the ecosystem or like the underlying ecosystem, not people who just want to build on top of it. Does that make sense?
I guess it makes sense. I object to your initial claim. I think you should instead try to help people write simple smart contracts the native way, and then the tooling and the environment will build up around it. You don't need much tooling to do simple things.
Maybe the problem is like you do. Like you see,
I've already got we've got tooling for the built-in actors. It could be improved a bit, but I spend all my time writing native actors with not good tooling, but good enough.
But the problem is that's what I'm saying. Like there are different levels of developers. Like a lot of developers who are building this kind of stuff, they're like a lot of them are just starting out. They're trying to like build some like simple smart contract. They don't have the experience you do, and like they need extensive tutorials. They need like really good debugging tools. They need simple languages. They need good libraries. All this kind of stuff. Otherwise, they'll just get stuck and they'll walk away and go to VVM.
Okay, but the idea that we should build all those things is, I think, crazy.
I know. It's like that's why I want to first target the people who are going to build all those things, who are also going to be more willing to deal with like some of the complexity here. And also, unfortunately, they're also probably going to be starting in Rust in many cases because they're going to want like even better performance. And they're in many cases they've already written their things in Rust. But that's what I've seen.
Working backwards, have we identified 3 individuals who want to write actors in something other than Solidity?
We've identified 2.
Okay.
At least. Well, I mean 3. Actually, technically 3. Yes. 1 and.
But we all know he doesn't count.
Fine. Fluence.
Okay.
And I believe Tableland also wants to do that.
Tableland
Yeah.
wants to do native actors on FVM.
My understanding is yes. I have to talk to them again. But my understanding is that they have some Rust code they want to be able to deploy. This is generally what happens. Is like people already have some complicated code written in something like Rust, and they want to be able to deploy this as a smart contract. Now, this is not always possible. So the trick here is that like there's no guarantee that their code will actually be performant enough to actually like be reasonable to deploy on chain. It might be too expensive, but a lot of people still want to be able to do that. They want to be able to like take some small part of the program that they've already written and like deploy that little part of their program on chain. And that's actually one of the first cases people have for.
Okay, so that's actually really interesting. Please pull me into those Tableland conversations. If you squint your eyes and turn your head to the left, Sashimi DA kind of looks like potentially what Tableland does, even though my whole thing when I looked at Tableland was, well, this is going to be far cheaper because we're going to do it natively, right? So if they're considering FVM and native actors, please pull me into that. But that will help you instruct first. Why are they going from EVM in, and then just solve those problems, and you don't try to boil the ocean. I think it'll be a lot easier to get the PMF that we need from those features. If you try to make a guy like Alex happy, like good luck.
Yeah, unfortunately, I was hoping they would both be here yesterday during the first talk, but I can think unfortunately all of the talks were shuffled around, and that was moved to the beginning of the week when no one was here. I think a lot of people were arriving today, midday, which is making this really tricky.
Tableland, they're here, right? Like.
Tableland is here?
Yeah, Andrew's here.
I haven't seen him at all.
Since yesterday morning in the intro section. But anyhow, I just want to mention that, like, even if you remember last night's conversation, we were even talking about data programmability, like user storage market or client contract, all those use cases people are not building. One of the reasons is because the cost is expensive for both client and storage providers to engaging in the FVM contract today. So if we can get the gas cost savings, it's going to be a huge win for, like you were even proposing, maybe we need to optimize per FEVM contract call, which is a waste of time in my humble opinion, if we can just have like native Wasm.
No, but we actually have the same issue in native Wasm where like there's a fairly large startup cost whenever you call another actor. Part of this is stuff we can't optimize. There are several parts there where we can. I was doing some work on this for this release, or sorry, this network upgrade, but it didn't get completed because of other bike sheds. But I'm hoping to, we could talk about that actually. That's an interesting interface and actor thing. Basically, right now, whenever you call into an actor, it has to first ask the system for a context, or like a message context, which tells the method ID and a bunch of other stuff. Then it also has to like stat the parameter block to figure out its size and its codec. Then it has to ask the system to actually read in the parameter block. And I think usually makes one of the it makes basically 3 or 4 syscalls up front, and that's not cheap. An alternative is we can, for example, pass in the method number in the function parameters when you call in. We can even pass in like the size and the codec of the block. We can also, like for example, with epochs and stuff like that, we can probably expose these as globals inside Wasm. We didn't do this for the very first version. So okay, Wasm has this concept of globals, where you can import like global variables from the environment, kind of like environment variables as you do in C. The tricky part here is that like there's no way to directly access these from Rust, which is why we didn't do this in the first version of the FVM. But later, as I learned more about Wasm, the answer to this is basically you write a Wasm module. It's very, very slim. It basically just imports the globals and then exports a bunch of functions that read the globals. And you write this directly in the Wasm assembly language. Then you have your Wasm module, your actor that basically just calls these functions, and then you run a tool locally that just links these two things together. So your final actor imports the globals directly, even though the code you write in Rust calls these functions that read the globals. The whole point of this is that means like you don't ever have to cross from the actor to the system and then back into the actor, which makes a lot of this stuff a lot faster. It doesn't solve everything. So for example, like we do have a lot of cases where like before we call something, we do something, we'll like check to see if an actor exists in certain cases, which really sucks. But it honestly will probably halve the cost of calling actor, or just that basic cost. There are a bunch of other costs there, but it should like make things much cheaper.
By the way, Consensus Lab is another user, right? They had to hire Solidity developers to write IPC contracts.
That's true, but they've already written them. But yeah, like there are a lot of groups. Again, like basically, it's the groups that want to write something complex, and they're used to these lower level languages, and they write the thing in Rust because and then like okay, they don't have to rewrite it in Solidity. They have to learn Solidity. Having Rust available just means that they can just go straight for it and just do it. And on it, like that's why I say I think these are really two different. They're really two different, I guess, types of developers trying to build on this. Like the people who just want to write the smart contracts, and they're not going to be using Rust. They're going to be using AssemblyScript or Solidity. And right now, like, just Solidity has just a much better developer experience. Not just because of the language, but just because like you have all these debugging tools and like chain explorers and like all this stuff, and just like a million tutorials to tell you how to do every little thing. You can plug in a question into ChatGPT and it'll just spit out a Solidity contract because there's so many tutorials as read. This is less the case with things like AssemblyScript, and then when you take that and combine that with the FVM, a lot of these developers will be lost. Then there's the other side of like people who are just like, they are trying to like do something really low level and really complicated, and they will often just reach for Rust, and they would be much happier if they didn't have to like learn Solidity and learn this whole smart contract ecosystem.
Yeah.
Found the solution to your question about the state. So we have a class state, and we use it to define the state in the contract, and we can then call a stage load. And I have shared some links to Maciej about how we do it, if that helps. Yeah.
Thank you.